You can start.
We can start now.
Yes, sir.
Good evening, everybody. I hope they would be putting some questions over there. I would like to know whether anybody is there and listening about it.
So only one viewer, sir, you can see.
One viewer.
Yeah,
Okay,
now it's
5
5
viewers are there. Okay, all right. So good evening to all of you. First, I would like to say sorry I was not active in this forum almost all the time, and my TA was looking after this. So because I was also away, and I'm not very happy that I was not able to give any response to you people. And I also understand there were few mistakes in the slide and in my talking, but somehow people insisted me I have to finish this one and offer it into this semester. So NPTEL people and everybody. So somehow I made it, but certainly there are hiccups in this, and I will try to improve that one. Some question is that I mentioned there were some confusions, so I will try to clarify about those questions. So probably what I will do, I will, you will see this next slide. I'm sharing this screen, and in that one, I would like to clarify most of your doubt. So you can tell me later. So these are the forum questions which came, and okay, yeah. Okay, the first I have taken only those ones which require some clarification. So the first question was in calculation, it was considered 365 days in a year. And I think this is the first question. Okay. All right. There would be a little bit made up in the question. So 365, but presently blast furnace working days are considered as 350 days, considering the capital repairs. What is the difference between tear gas and hot blast? So 365 is just a general term, which is a convenient one, because in a year you have that has been taken. But you can take any of the days and you can calculate depending on that the requirement of the raw material or anything. And that's how I have put it. One can calculate for any number of days, depending on the individual circumstances about the industry and other things. So it need not to be even 350 days. So that's easy. I don't think there should be any problem. The other question is, what should be the ideal proportion of waste fines in a sinter? So the answers are giving with the arrows. So where are arrows indicating those are the answers for that particular questions. So in this case, so there is no ideal proportion. It depends upon the size and properties. So some fines may go to pelletization and some may go to sintering. And because sintering and pelletization, these are the agglomeration process, so one has to use the fines. So there is nothing like that one has to use only 20% proportion in the sinter. Sinter, you make it only from the fines. And same thing about the pelletization, except that the size, fine size is different in both the cases. That has been explained there. The third one is numerical about total iron input in slag, where it is given A into capital S divided by 100 equal to 149. That is true. It is actually wrong. It should be 128. The division by 100 is just removing the percentage sign. So it should be actually 129 approximately. So that should be clear. If you have any question, just type it and I can see that. Another question was in the forum, what are active coke zones? So mostly the coke region below the cohesive zone is known as active coke zones. So excluding the dead man. So this is the zone where coke is the only solid material exist in the blast furnace. So that is mostly known as the active coke zone. Melting point of P2O5 360 degree, then how is it getting reduced in blast furnace, that too at lower zone, and how phosphorus is entering inside hot metal as impurities, its boiling point is 280 degrees C. I think for that purpose, you should be very aware about the thermodynamics and the kinetics of the process. And I'm sure people must have taken this metallurgical thermodynamics in your undergraduate, and that is the basic course for that. So phosphorus actually is combined mostly with the calcium, and that I have written that mostly phosphorus comes from coke and very little amount comes from flux, and it is combined with calcium in the form of tri or tetraphosphate. And silica breaks it into P2O5. So that goes at higher temperature. So if you look at probably a Ellingham diagram, phosphorus infects sublimes around 800 degrees Celsius to P2O5, and then with the carbon it gets reduced around 800 degrees Celsius. So you are, and even this calcium phosphate, which breaks down by silica, it occurs at high temperature. And then this P2O5, it mentioned also it can vaporize and melt. Immediately carbon react and makes the phosphorus, but that phosphorus comes into contact immediately with iron in the lower part of the blast furnace, because this is coming at the lower part of the blast furnace. Phosphorus is combined with the calcium. So it cannot occur at the upper region of the blast furnace. So phosphorus get absorbed within in the liquid iron, and 90% of phosphorus goes to metal, and remaining 10% which may escape, it goes either in slag or flue gases, and some in the refractory. But this question also again is just like a sulfur. Sulfur, if you think, it also has the same thing, a lower melting point and other thing. And that also we have explained. So mostly you have to look at the reaction, then the thermodynamics of it, then the kinetic constraint of it, and it is not just the pure. It is actually at ppm level you are talking. So homogeneous system. So all these dictate the equilibrium of it, and how much for enter into the metal and how much into the slag. And that's why this is all written about the oxygen potential, temperature, basicity of the slag. If you remember, for the sulfur, we had a sulfide capacity and activity of oxygen, which is nothing, the FeO content in the slag. So on all those factors, that depends. The next question in the forum was, what is more efficient for a blast furnace, a smaller cohesive zone or a larger cohesive zone? If it's smaller is more efficient than during study of area zone. In furnace, we saw furnace with a smaller cohesive zone to more a defect like scaffolding. Please explain. Though I have written the answer, it's more about the thickness of the cohesive zone and not about the smaller or bigger size of the cohesive zone. And the most important point is about the permeability of the cohesive zone. So when it is descending, whether this layer structure is maintained or not, that is very important, because the layer of iron ore, it becomes semi-molten in that cohesive zone. So gas cannot pass through that easily. So mostly it passes through the coke layer. So that structure has to be maintained. If get mixed, then lots of resistance to the gas and very high pressure drop. So it should be thin. It's nothing to do larger or bigger. And if you look at that lecture 3 and the figure into that, you will see that cohesive zone in the right side picture is quite thick, and it's a sort of a mixed one and not thin actually, and not keeping the structured layer. So that one really is offering lots of gas resistance, and due to which many defects are coming into the picture. That is actually the main reason of it. Okay, this is in lecture 19. It has been clearly mentioned that there is a substantial increment in value of total hold up in presence of gas flow than in absence of gas flow. That is why I had marked option B in spite of option A in question 10 of assignment 4. Please clarify reference lecture 19 time this. Here actually one problem was given to you, and you are supposed to solve the problem, and not based on a qualitative analysis you give the answer. And what I am feeling, what answers you are giving, your answer is totally based on the qualitative analysis, what was said in the class, and not based the numericals. There is no point of then giving the numericals or solving it. You haven't solved it. If you solve that numerical, you will find the correct answer. So I would recommend that you should solve first the numerical and then look at the answer and then decide which option would be the correct one. So I will not give the direct answer of this, but I would refer you, please solve the example first and then look at and then read the question and then see which would be the right answer. The next question is, I have answered raceway. Instead of one word of raceway, can course admin consider my answer as correct in exercise 5 question 9? So this is well, I have to talk to the admin and maybe I may give a benefit of doubt to you, but I'm not sure whether it can be done or not. So I will look at it, talk to admin. If it is possible, we will try to do it. If not, please don't mind. It's as such your mistake, but we will see if something can be done. Another question is, the formula which was shown in lecture 26 was not giving the answer as per all 4 available options. Kindly rectify the doubts, and I have attached those things file regarding the query which will clarify your doubts. Yes, This all actually has been posted by you. The answer is you are correct. Actually, the correct answer is 8.28, is using 10 to the power minus 6. There was a little problem in this slide, it seems. So, this ion density is using the first slide where 10 to the power minus 6 is given in the formula, is correct one, and that would be the correct answer, 8.28. So yes, sorry for that, and we will see what can be done. I think this answer will be given. Another one, in assignment 7, I have opted correct answer for question 18 and 21 according to your provided answer key. Yet it is showing wrong answer in page. Please do correction to my assignment score. Okay. This is okay. The question, as per the screen shot above, it seems that silicon content in hot metal keeps on decreasing at the end of blow-in process. So as for this, option C should be the correct one. Also, as the blowing process starts and continue till end, we gradually increase the blast volume. Coke rate will gradually decrease as we continue the operation. So, but we see above option D and don't have such possibility. This is quite confusing. So, by practical experience and as per lectures, option C was most viable option. Here, actually, you are wrong. Please read the question carefully. Question is saying from start to end. Read it carefully. From start to end in blow-in method of blast furnace, the following keeps on decreasing. Your silicon content, it keeps on increasing quite a lot time, and then it start decreasing. So that is not the answer at all. First, when you have not read the blow-in sequence, how it is done. If you have read it properly, this question should not have come. Because in the blow-in in the starting, it is filled with the coke, mostly with the coke. So the coke rate is very, very high. And where you put also some siliceous material and other thing, and coke S is generated, and that's how you get the silicon content high. And because your coke is quite high, you have to blow more gas to burn it. So your blast volume and coke rate both are high in the starting. And slowly, slowly they reduce and come to the normal one, and that's how even the silicon content comes. But silicon content is very high in the starting. So C is not the answer, D is the answer. About the question number 21, where there was a doubt, midrise is a gas-based or coal-based. Yes, there is a wrong answer in that one. It should be option B. It is a gas-based. So that's the correct option, option B. The next question is, I want to know this, I think this NPTEL guy we have to ask, and I will see what can be done to this NPTEL people if whether it has been withdrawn or why it is showing to withdrawn sign. So we will correct that one. Certainly I have to ask them to help you out. And it will be taken care of, that I can assure you. If you have a problem, please contact me on that way directly. Okay. The next question is, please find a test doc file related to question number 10 of assignment 8, in which I have given detail about the query. Okay, it is about the fluidized term. Yes, both the spellings are correct. Actually, the one which is used is a more British sort of one, and other one is the American, and so that's their confusion due to that, and it has been corrected already, and you might have seen that correction in your mark. Okay, there are some questions for this session which have been asked by the people. So I'm going to take those questions also now. So one is, as many of the students of this course are in service, we may not be able to calculate metallurgical calculations fast. We kindly request that the end exam may have more theoretical questions than calculation. I would say that question paper cannot be set according to the individual preference. So I would not like to comment on this. What should be the standard pattern and things, it should be on that way, and people have to prepare that way. It's not with the individual one, we can do it. Instead of having a single huge block, there is a one person has not enrolling in iron making by son withdrawn.
I think he manually withdrawn. Automatically it will not happen.
No, he had not withdrawn at all. That's why he's saying, why in front of me, it is in front that
Yeah.
he is saying he wants to give the exam, but in the sheet it is showing withdrawn, which he hasn't done it.
Okay, he can send a mail to nptel@atm.ac.in, so they will reply.
Probably he did that one anyway. That's why I said, you please send again, and can send a copy of it. So a copy of it to me. I think even in the forum, I will check it tomorrow. If it is not done, I will talk to them. Okay, coming to the question of the this live session one. The second one, instead of having a single huge blast furnace, can't we have a 7, 8 small blast furnaces? One of my students said something like for the cooking one, if we have a cooking in 8 small pan and cooking maybe in a one big pot, then what would be the difference? And according to her, lots of energy would be wasted. All tests from 7, 8 of them may not be the right. It would be different one. Labor consuming, time consuming, and many sort of things. And I feel probably the same thing goes here, that small blast furnaces are less productive, more resources needed, etc. They are okay where you have a or you have to cater for a local need, and that is where actually they want. So you can they don't. It doesn't matter that you need a very big production or like that. At the moment, the demand is about the productivity and the high production. When you put this mini blast furnace, these are the localized ones which can serve the local demand. So, and because these are at a small scale, so it is easy to set them up. You don't need a very high infrastructure, and the expenses are low. So that's why they are preferred in a localized way. But they cannot be compete with the blast furnace where you need really high production if you are looking at national level. Another question, can we get a graph showing the profile of the cases with the height of blast furnace? For example, PCO2, PCO2, P oxygen. Instead of using a large furnace, why don't we have a small furnaces? So for the second one, I have already given the answer before. For the first one, I think you can find in quite a few papers, if you do a little research, or even in some of the books, these graphs. One actually, I have seen it in A.K. Biswas, the reference of which is already given in the lecture. In that one, there is a figure at page 267, which shows about the CO utilization curve in the whole blast furnace. And from that CO utilization efficiency, actually, it shows the NCO efficiency of the CO utilization. You can get all these first three of the options. You have to just efficiency of CO utilization, content CO, CO2, so you can easily convert them. And that graph is already there. So I don't think that's a big problem. One has to really look at the proper sources. Chemistry of blast furnace. I did not understand what is the meaning of that chemistry of the blast furnace. We have already taken this in some of our lectures where we talked about iron carbon, iron oxygen, iron carbon oxygen, and hydrogen carbon and oxygen diagram phases, and where different chemistry was discussed and how various type of reduction occurs. So we have talked about it. I don't know what is specific you mean by this chemistry of the blast furnace. If you can specify in a clear term, probably I may be able to give the answer. The next question is, please say take some numerical from the topic. Again, I think it's a problem. I again did not get it in a proper way, because in most of the lecture which I have taken, I make sure that I support that one with the examples, and most of the places I have given enough examples for that um, related to that particular topic. If you really want me to take some topic for which the example was not taken, I think you have to specify it clearly. Otherwise, for most of the important topics, we have taken quite a few examples. The next question is, pig iron is a product of blast furnace. Is there any alternative to produce pig iron to reduce the expense and eco-friendly technique for the future? So yeah, so pig iron is a product of blast furnace. Is there any alternative is actually a Corex process. Corex is a commercialized one where it has plants in some of the countries, including India, China, South Africa, Korea, and a few other places. Similarly, Phoenix, as such, is not commercialized yet, but POSCO, the South Korean giant, they claim they have started and POSCO in Pohang, this Phoenix process as a commercial plant, probably up to 1.5 million ton. So these two are the one probably I can say producing the pig iron, but they cannot compete at the moment to blast furnace in terms of production. But certainly they have some advantages, especially Phoenix, because directly you can use the coal instead of coke, and you can use the points. So you are removing many other ancillary unit in between. So, but it's still there's a long way to come of this technology to compete with the blast furnace. A new one is also coming up. A pilot scale plant is already there in US on the hydrogen reduction process, which is again a fluidized beds process where one can get the pig iron and maybe a much better composition. But again, it's just trials are going on, so it will take a long time. Otherwise, there is no other process at commercial level by which you can produce the pig iron. I need proper material and guidance. I don't understand by this. What do you mean by that? It was already, I think, given. So if you have some questions or something, you can type it, or you can tell me. This is all actually I want to give the clarifications. Hmm?
Type in the chat. Type in the chat.
Here it is not coming.
No, just tell them. Type in the chat window if you have any questions.
Oh, okay. I have to probably. Here I have to type it.
No, just tell them locally. Type in the chat window if you have any.
Yeah, in fact, I told them if any of you would like to discuss anything or want to know something, could you please type your question so I can answer that one? I have tried to answer most of your forum questions and something which you have sent for this live session. So if something which is not clear, please let me know. As you can type your questions. I'm still waiting for that. Or any comments, any suggestions you want to give. Your question, final question could be on the same pattern as your this assignment was. So it would be totally objective in nature. So it seems now you don't want to ask any question. All the your doubts, confusion, everything is clear by now. There is no other question, huh? Don't hesitate if something is there or even some silly questions you feel it is. Just type it and let me know. I can see there are many viewers, 17 or so. So are they getting the message? I'm not very sure. Okay. But I don't. But at least if you are getting or you are able to listen to me in a proper way, just write that everything is okay. So I can know that you are watching and you have heard me properly and nothing more is there.
Live chat window.
Hmm?
Live chat window.
You open.
Tell them live chat.
Live chat. So live chat window, if you open, you can type your question or whatever.
Sir, you're audible. Yeah. Somebody is
Okay.
somebody.
All right, but I haven't got here. Okay, but why it is not coming here? Well, thank you. At least telling me that I'm audible, Mr. Shah. That's nice of you because on my screen I can't see it, but on some other screen I was able to see it. So that's okay. It's good actually. Well, if you can listen to me. So any question which you people want? Any question? Yeah. Probably I will follow this. At least I can see the question here. Your lecture is good. Thank you, Ms. Meena, for giving that compliment. But I'm looking more for the any doubt which you are having, so I can clarify those doubts. It seems on my screen I'm not getting those your messages, but on another computer I'm getting it. So I'm looking now for the computers so I can see your questions. Seems some of the viewers have joined at later that they did not stick to the time. Now I can see 21 viewers. But so if anybody wants me some particular question, I can still repeat that.
Please give the review of the topic before questions are asked.
Review of the topics. I mean, what do you mean by review of the topics? Because I feel whatever I have taught, question can come from anywhere in depth. So, or you are talking about the giving the summary of each lecture and things. I don't think at this stage it is possible. That cannot be given. But if you have not understood something, you can ask me. I can clarify that. So, if you have a particular question, then please ask. I can clarify that one. Because final exam would be covering the whole course which as you have taken. Okay. So, any other question? Okay. All the topics would be covered. Whatever you have been taught in those lectures.
So, Sir, please give this one. Why are we going for different methods to add magnesium to the iron? Well, like German, strong, etc. What are the advantages of the iron?
Different methods to add magnesium.
To iron merit, like plunging, German agitator, sprinkling, etc. What are the advantages of iron?
Well, Mani Deepka, I got your question, but really this question is not the part of this course at all. We don't really add the magnesium, particularly in iron blast furnace. But if you need a high magnesium pig iron, sometime probably for nodular iron and other things. So that's a separate topic which we are not dealing in this course. So I don't think this is really needed, the answer. So, and so this is not the part of the course really. Any other question relevant to this course which you are taking?
Okay, sir. Okay, sir.
We haven't discussed even the magnesium in the course. We discussed more about the phosphorus, sulfur, silicon, manganese. Any others questions by anybody else? We still have around 15 minutes. Also, you can give your suggestion on this course. As I mentioned in the starting, I understand there are few mistakes in the slide, and even probably in talking at some places, things are not matching with the slide. I found it at 2-3 places, but this we will take care um, if the course is offered again. Beside that, if you have any other suggestions for this course, you can always write or send your feedback. Okay, any other? So it seems most of you understood the course quite well, and it seems you are not having any problem. And that is why there is no question. So probably I should wish you all the best for your exam. and do well. So still, if you have some question, please let me know. There was one question related to environment of the Central Board pollution control norms. But again, this is outside the scope of this course. That's why I did not answer for that, because those norms are quite different and we haven't talked about the policy and norm related to environmental problem of pollution related. So any other question? I'm trying to look at your forum things. If there's any other question which I left unanswered, probably I can give a reply. So I have to here tell you one thing. When I was talking about this question number 18 in assignment 7. So those who are given option C, that would be wrong. So marks would be adjusted accordingly. So I have to talk to admin about it. So no other question it seems coming from anybody. I'm quite happy that everybody understood about it. So how many of you are a student? Um, can you tell me the um, um,
So you tell them type if you're a student.
yeah, could you please tell me how many of you are students? So you can just type it so I can know, because the way it was discussed in the forum and even in the live session, one question came that most of you are working in the industry or in the service. So can we have theoretical questions instead of numerical one? So I also wanted to know the sort of statistics, how many students are taking and how many people who are in the service are taking this course. because I got a few requests before starting the course from few students and even from the college. They, that they want me that this course should be offered this semester. Well, thank you, Mr. Shah. You are quite active and I am happy you are responding and you learned something from that. Thanks for checking. But are you working somewhere in a company or what are you doing? Is it helpful to you if you are working in the company? Recently, I took the course organized by AICTE for teachers on iron making. And I was a bit surprised the way they were teaching the iron making. And many of the teachers who were teaching this course, they were having a mechanical background. And they were really not aware about the blast furnace from metallurgical viewpoint. So mostly they were paying the attention toward the mechanical side of the blast furnace, how to construct and those sort of things, which is really, I felt like a part of the mechanical curriculum, not for the metallurgical curriculum. And I hope by this course, many of the colleges and people will get benefit who are working in metallurgical field. And sure, it is not the final one. There are some, or this can be still improved, the course, but your suggestions would be helpful. So I think another 4-5 minutes. If anybody has any question, it would be good. Otherwise, after probably 4 minutes, I will disconnect it. They can always, how do they contact? Through the forum.
So, any questions?
So anyways, you can always put your question in the forum and I will come to know. So if you have any problem in relation to your marks, in relation to any other things, just write it into the forum, and because now I'm here, I can look at those and I can reply. Well, Mr. Shah, that's correct. Question and answer in an interactive way is most useful. And that is the reason actually I gave this time. And I asked NPTEL especially to make this interactive session so people or students or any other who have doubts and things, they can probably talk or write their doubt and I can answer immediately, because these are the most effective and useful session where you are talking directly to the lecturer, because otherwise many times behind the scene the other TA or other students are working and giving the answers, so you really don't know. So I expected more people would be asking the question in this session, except 2-3 not others, and that was the purpose of this session, that to encourage people to ask their doubts or any other things if they have in their mind, so I can explain it. Because already I felt sorry that many of the doubt I couldn't clear in the starting, and there were few mistakes also. I thought I should take this interactive session and clear all the doubts if anybody is having. So I think most of your questions in the forum questions also I have answered, and you all would be satisfied with them now. Any other particular question if you have, please do so. Otherwise, I think time is running out. I probably have to stop this broadcast now. So again, good luck to all of you for your exams on 28th, on 29th of April. Do well and good luck. All the best. Okay.